Please remember there are additional resources and things such as code samples at elithecomputerguy.com. So if you're watching one of these classes and you need to know what code looks like, or if you need links to the resources that we're using, please go to elithecomputerguy.com and take a look at our class posting there. Also, please remember that free to the end user classes are not actually free. It costs me a lot of money to be able to provide this type of content. So if you could click on the donate button and throw in a couple of dollars every month, this will help me be able to continue to provide you this type of material. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we are going to be learning how to write our own custom functions in Python. Well, I'm gonna tell you a little secret from an old timer in the tech world to the new folks. Do you know how an old timer in the tech world can tell who a noob is? The noob is the one that's stating that they handwrite all their own code and then that they would never reuse anybody else's work. That's how you can tell the noob, because the old timers are like, wow, cool, kid. I've got like a house and a spouse and a dog and other crap that I want to do today. If you literally want to rewrite code that somebody else already did 10 years ago, good for you, but do not expect any pats on the back. And to be frank with you, when you're the first person to get laid off at your company, don't be surprised, right? One of the big things to understand in the technology world is that we are a profession of copy and pasters. If you can copy it and you can paste it, that's the way to go. And again, I'll tell you another secret. That's what your boss wants, right? If your boss is paying you $50, $100, $200 an hour, and you could sit there and handwrite all this code and it'll take you 4 hours and cost him $400 or $500, or somebody can copy and paste a snippet of code and that takes 5 minutes and costs him $20. Which person do you think is going to be working at the company longest, right? We copy paste, right? Reusability is a core component of the tech industry, right? If somebody else has already done it, grab the work that they have already done. But also for yourself, if you can create code and simply reuse that in the future, that's the best way to go, right? Again, I talk about, I work on projects with OpenCV, computer vision. I work on robot projects, that type of thing. And here's the deal. Like a lot of the code that I use, I figured out how to do that code like 2 years ago. I threw it in a notebook. And now when I'm doing a new project, right, I flip through the digital notebook, I copy that chunk of code, I paste it into the new VS Code script that I'm writing, and away to go. Why am I going to rewrite 50 lines of code or 100 lines of code when, Control C, Control V will do it just fine? And so this is a very important concept to really be thinking about in the tech industry is, again, how can you reuse code? How can you reuse anything? And when you initially design something, how can you package it in such a way that it can be reused in the future and also so it can be easily maintained? That's where functions can come in with Python. And so what functions are is essentially, think of them as small, teeny tiny little programs within your overall larger program, right? So again, we talk about things like SMS messaging. So imagine that you have a function within your program that actually connects to the Twilio servers, takes the message that you want to send, combines that with the SMS phone number that you want to send to, and will just go through and continuously send messages until it's done. So let's say you have a list of recipients, and for all of those recipients, you just simply want to send an SMS message. So you can feed that list to this Twilio function. It will simply go through, and for every value in that list, it will send an SMS message off. And so what you can do is you can write 5 lines of code once, and then just continuously reuse it, right? So basically, if you're doing basic math in your code, using a function, right? If there's math that you're going to be reusing, basically just create a function out of it, call that function throughout your script, and then you can write it once and call it from all of the other locations in your script. The other thing that's nice with functions is if you compartmentalize everything into a function, all this logic into a function to do a specific task, then when somebody down the road needs to maintain the code that you've created, it's much easier to figure out what's going on with that specific function than looking through, again, 100, 200 lines of code to find individual things that you fired off or you did within the code, right? If you're reading through the code and you're like, oh, here is where I call the function that sends Twilio messages. We've been having a failure with Twilio message. Let me go find that function, the code, and then you just got this block of a function. And then you can see, and it's like, oh, Twilio modified how you do the API calls, a couple of weeks ago. And so within this function, I simply have to modify one line of code right here on how I make that API call to Twilio. I do that, and it's fixed, and we go on with life, right? Isn't that much easier than, again, if you just have this Twilio code just in this 200 lines of code, it can be a complete mess and it can be a disaster to maintain. So when we're dealing with functions are going to be incredibly useful, not just for you, but also for the people that are going to be maintaining your code, long after you've left the company or organization. So danger, Will Robinson, danger. In the technology world today, we are going to the most dangerous of spaces. You've heard about the dark net and the deep web and all of that kind of stuff. That pales in comparison to where we're going today. Today, we are going to namespace. Yeah, okay, this is all going to kind of suck for you. Hi, are you a noob? Welcome to misery. Okay, so one of the things, as we're going through and we're going to be dealing with functions today, one of the things to be keeping in mind is things such as namespace, flow execution, and scope. So what does namespace mean? Basically, it means that you have to make sure you don't screw up what the hell you are naming things, right? Remember, in the technology world, whatever you're dealing with technology, again, whether it's a Python script or whether it's an Active Directory server, you need some type of unique identifier to signify whatever the hell it is that you're trying to interact with, whether it's a function, whether it's a variable, whether it's a server, right? You have to have a unique identifier. And so in the Python world, we're going to be using function names and we're going to be using variable names and that type of thing. One of the things that you have to be careful about is if you have two variable names that are identical, hopefully your code will fail. You're like, what do you mean hopefully the code will fail? Well, because if it fails, then you know there's a problem. If it doesn't fail, there's still a problem. You just might not know it exists, right? One of the things we talk about when we talk about namespace is that you can't use the same name for multiple different things. They talk about this with WordPress programming. So, WordPress, the content management system that like 90% of the planet uses. I've talked with a lot of coders in the WordPress space, and one of the big problems with plugins for WordPress is there's no system for like validating things like variable names within those plugins. And so one of the things that might actually crash your WordPress site is if you install 2 or 3 different plugins, and those plugins basically have functions or they have variable names, and those names are identical to each other. Then basically when WordPress goes off to fire off a function or goes to grab a variable value, there will be 3 literally different ones that it has to go for, and then things might crash and things might be bad. So be careful about this. We're going to be dealing with this today with something called scope. So what scope is basically where variables can be accessed from within your Python script. And we're actually going to have a lab on this much later. But basically you have global scope. So you create a variable, you set the value, and then anywhere in your script you are able to access that variable value. You also have something called local scope. For things such as functions, you can actually create a variable inside the function. The variable value will only be accessible inside the function unless you do something else. And again, I'll show you that later. So one of the problems you can have is if you create a variable outside a function, it can be accessed outside the function and inside functions. If you create a variable inside a function and you don't do something special we'll talk about later, if you go to try to access that variable somewhere else in the code, it will fail because it is a local variable, not a global variable, and so that you'll run into issues there. So again, this is just one of those things to keep in mind, and I think as we go through this class, it'll start making more sense. The other thing is flow execution. So I've heard this from some coders that hate Python. I know there's some coders out there that hate Python. That Python flows in a very specific way, and it only flows in one way. So what this means is when you're setting variable values, when you're defining functions, when you're doing all of these things, you have to do that before the thing is called in the Python script. So basically the Python script simply reads down. It reads from the top of the script to the bottom of the script. And so when you're going to access a variable, you have to create and set the variable before you call it later in the script. So if you call a variable that is set later in the script, it will fail because that is before it has been actually set by the script. If you create a function, but call the function before the function is in your script. So let's say you try to put the function at the bottom of the script instead of the top of the script, it will fail because you haven't created the function yet as far as Python is concerned. And so you have this flow control where Python reads from the top of your script down. And so when you're calling for variables, when you're calling for functions, you actually have to make sure that variable or function has been created and defined before it's called in the script, not simply that it's been created in the script, because you can run into some, we call them quirky problems that way. So anyways, we're going to be talking about this more during the class. I just want to give you a heads up on this, because especially if you're new, this can be incredibly frustrating. There's nothing so frustrating as, again, properly creating and defining a function, but then having your script fail because you're calling function before you have it in the script. And so even though the function is written correctly, how you're calling the function is wrong and can lead to all kinds of frustrations. So now let's take a look at our very, very first function. This is a very, very simple function. In order to define a function within Python, the first thing that we're going to have to do is say def. So def space, and that's how we say that we're going to be defining a function. We then say what that function is. So here we're going to be calling this function hello, and then we open parentheses, close parentheses. So nothing is being sent to this function for this particular lab, so we don't put anything in there, but that does need to exist, and then we do colon. For this particular function, basically all we're going to do is every time this function is called, we want to print out a message. So again, think about this with sending out an SMS message, something that you're going to want to repeat a lot within your program. You don't want to have to rewrite that 1,000 times. Basically here, you can create your function. You can print hello world, this is cool, or you can print whatever message. You can print an error message, you can set up an email system, whatever else. And basically, from now on, all you're going to have to do is you're just simply going to have to call that function. When you call that function, anything within the function will be fired off, and it makes life a lot easier. So again, you write the function once, and then you can call it as many times as you want. So with this, basically we define the function here, we call it here, and then we run it. Hello world, this is cool. So exciting and amazing. But what's nice about this is, again, this will seem pretty stupid, but I can simply do hello, hello, right? So I just call this as many times as I want. And so all I'm doing is I'm writing the function name instead of the rest of this stuff. And so if I go to run this, it will do hello world, this is cool, hello world, this is cool, hello world, this is cool, hello world, this is cool. And so that's what the function allows you to do, is it allows you to create that code that can be reused throughout the rest of your program. Again, this can be really good, especially when you're new, for things like log files, for things like messages, any kind of repetitive tasks. Now, one of the things I told you before was that whole flow control thing, And this is where we got to be careful, right? So we define the function hello here. This is the function, and then we call it. And when we do this, just to verify, it works perfectly. But remember, it is reading from the top of the script to the bottom. So if I do Control X, Control V, so now I am calling the function before it has been defined, and then I try to run this, I will then get a failure. Name error, name hello is not defined. Did you mean help or something else? So you called this before the function was defined, and therefore it failed. So you have to make sure that you define the function first, and then you call the function in order to make all of this work right. Again, it's simple once you understand it. Until you understand it, it can be slightly frustrating. So now let's look at sending a variable value to our function, right? So we're going to define our function up here, say underscore hi, and then we're going to be sending a variable to it that we're going to call name. Down here, we're going to create a variable called person, and that variable is going to be set to the value of Bob. We're then going to come down here, we are going to call the function and then put in the variable. Now the interesting thing is you'll notice when I call the function, I use the variable name that I created for this part of the script. But if I go up here to the function itself, I have a different variable name that I'm using in the script. So what's important here is the positionality, the position of the variable that is being sent to the function, not actually the name itself. So down here, I'm interacting with a variable named called person with a value of Bob. So I could do a lot of stuff with person here. I'm then going to send person up to the function. But again, remember with functions, we want this to be reusable. So here, I'm calling this person, I'm naming this person Bob, but maybe in a different script, I want to call the person a student. In a different script, I want to call the person a teacher, right? So in different places, I could be using different variable names to basically deal with the name of a person. So here is where we have that variable name. When that gets sent up to the function is going to then grab the variable value, and then it's going to interact with the variable based off of the name that we create here. So down here it's person goes up here, and it's simply going to be called name because we decided that's what we want. So again, this could be student, this could be any number of things. Then here, so we define, say hi, name is the value that's being sent, and then we're simply going to do print F string, single quotation mark, hello, squiggly bracket name. So this will be the value of the variable that was sent up. And that's all that's going to happen, right? So we define the variable, we set the value for person. We then send the value of person up to the function, and then we're going to print out hello, Bob. And so when we do this, we get hello, Bob. So exciting. I swear, it gets more exciting once the stuff gets more complicated. So anyways, now what I want to do is, again, we've talked about that whole reusability thing, right? It's not really about, okay, we can say hi, Bob, right? So again, like up here, you're like, okay, why do I need a function to say hello, Bob? I could just say hello, Bob. That doesn't make life easier. What you need to be thinking like is you need to be thinking like a programmer. You need to be thinking about a coder. How can we simplify this process in order to trigger some kind of function like this in the simplest way possible, right? And again, think about this if we're sending out emails. If we're sending out emails to 1,000 different email addresses, we don't want to actually have to type that out. We want to be able to do something like go through a list. So what I'm doing down here is I have a people list. So the people list equals, again, square brackets, because this is a list, Bob, Sue, Tim, and Fred. Right? And this could be 1,000 people. Again, it's imported for something, could be 1,000 people. It doesn't matter whether it's 2 people or 1,000 people. This one line of code will be able to do everything you need. So we're doing a for x loop, basically for every value in the list. And then we're going to call it person. Just to make life easier, we're going to call it person. Again, when we do the for x loop, this could be x, this could be y, this could be Bob. You can have any name you want. We're going to do person. So for person in people, so for person in people, say hi to person. right? So it'll go Bob will be sent to the say hi function. Hello, Bob. Sue will be sent to the say hi function. Hello, Sue. Tim to the say hi function. Fred to the say hi function. And again, if we had 1,000 names in this list, they would all go through and they would all be told hello. So we're going to go and we're going to hit the run button. Let me do Control S. I'm going to do the run button. And so with this line of code, hello, Bob. Hello, Sue. Hello, Tim. Hello, Fred. Right? That quick, because basically we're just going to be simply calling this function from this for loop that we created. And, as I was saying, we could be pulling all of this information out of a database for literally thousands of values. And for thousands of values, we still need 1, 2, 3, 4, 5 lines of code. That's how this kind of reusable code becomes so powerful. Now, in the previous examples, we were printing things out directly from our functions, right? So we send the name value up here, and then we're printing the name value up here inside the function. Most of the time, this is not how you're going to be interacting with functions. Most of the time, you're actually going to be wanting to return a value so that you can do something with it. And so with this particular function here, we have a return of the variable name, and so this value will then go later in the script, and we'll be able to deal with it in order to print something out or in order to make a action happen. So with this, I've created a little porn name script because I don't know. It's hard being a teacher sometimes. You're like, crap, I need an example. What example am I going to do? Porn names. So anyways, with porn names, the idea, as I understand it, is it's the name and the name or type of your first pet with the first street that you lived on. You combine those together and you get your porn name. Anywho, so basically up here, we have our function. I'm going to be talking about that in a minute. Let's just skip that for a second and come down to the variables and then calling the function. So first underscore pet, so this is a variable name for the pet, is going to equal a goat. That was actually my first pet. First underscore street is going to equal main. I have no idea the first street that I lived on. But anyways, I have a pet of goat and a street of main. Then what I'm going to do here is I'm going to create a variable called response. And response is going to equal the porn name function. So we defined a porn name function up here. I'm going to be submitting first underscore pet value and first underscore street, right? So first pet goes here, first street goes there. We come up here to this porn name function that I created. So define porn name. So the first value that comes in, within the function itself, we are going to call it pet. Right? So these names don't have to be the same. It's the position that matters. First position is here, second position is here. So first pet is how we interact with it in this part of the script. From here on out, we're within the function, we're just going to call it pet. So pet, comma, street. Then we're going to create a variable called name. So name equals f-string, squiggly bracket, street, space, pet. Right? So it's going to give you main goat. Right? Then you're going to return that variable, that value that you just created. So name is going to get returned here. When name gets returned here, that then is now going to be the value for response. So response equals porn name, first pet, first street. Combine those together into name. Return name, this value will now be the variable that you have here, which will be response. We can then do print f-string, your porn name is, what the response is, right? And that's basically how it goes for a return. So if I go and click run here, it'll say your porn name is main goat. I don't know. Is that a good porn name? I don't know if it's that good porn name or not. So anyways, this is what a return looks like. And this is going to be one of the things that gets really confusing for new people, is understanding things where the position is what matters, not necessarily the name. Again, it's called first pet here, but in the function we call it pet. It's called first street here, in the function we call it street. The reason is this index value goes to this index value, this index value goes to this index value. The index is the important part, not the name itself. Then within the function, you will call the name that you created up here. Again, when you return, so you're returning the value of name, that is going to then be the value for response. So response equals porn name. Name comes down, and then you have that response value, and then you're able to print it out or put it into a database or something like that. Now, just to kind of hammer home this whole thing with the return value and the idea of indexes versus the actual variable names. So for this, basically what we're simply going to do is we're simply going to add two numbers together. So I don't know, some kind of tallying system, that type of deal. So we won't worry about the function for a second. We're just going to come down here. So we're going to say price 1 equals $55.12. Price 2 equals $10.45. Response, right? The value of response is going to equal the myMath function. We're going to send up price 1 and we're going to send up price 2. Now, again, if we're just adding two numbers together, sometimes it's prices, sometimes it's other things. So when we come up here to the myMath function, here we're going to call it num1 and num2. So price 1 corresponds to num1, price 2 corresponds to price 2, then we do the colon. Answer equals num1 plus num2, so these will simply get added together. That value will be sent to answer. Then answer is going to get returned. That value is then now going to be the value for response, and then we can simply print out the value for response. So 5512 plus 1045 is, I don't know, 6557. Is that right? I don't know, something like that, right? So I could go here and I could say 885 plus 9045. And again, I just simply modify these two values here. I then run this, and apparently that is now $975.57. So that just kind of hammers home, again, down here in the rest of the script, it's price 1 and price 2. When I go up to the function, we're then calling it num1 and num2. And again, you can be doing everything from doing F string, creating F strings. You can be adding numbers together. As we go through and we start doing more complicated projects, this is where we're going to be doing things like API calls and that kind of stuff. But it just shows you how to create that reusability with a function. Now we're going to take a look at returning multiple values. So let's say you have a function like this particular function and you're trying to pull multiple values for some reason. So with this, basically we're going to have a list of prices. I want to know the highest price in the list. I want to know the lowest price in the list, and I want to know the average of all the prices of the list. And I want those values returned so that I can do something with them. So let's put the function aside for a second. Let's just come down here. So we're going to create a list called price. Again, square brackets is for list, and we're going to have four items: $11.20, $55.60, $27.33, and $25.66. That is in our list. We're then going to do response. So again, this can be called anything. I'm just using response because it's my standardization. You could call this Bob if you wanted, as long as it's not called something else in the script. Anyways, so we're going to have response equals the price stat function. So I created a function called price stat, and I'm going to submit the entire list, the variable price list, up to this price stat, right? Then when this goes up, right, so I've defined DEF, price underscore stat, the value that comes up within this function, I'm simply going to call it price just to make my life easier. Then for high, we're going to create a variable called high equals the max in the price list. So max list will give you the max value in the list. Low is going to equal the minimum value in the list. So whatever the minimum value in the list is. And then average, we have to do a little bit of math. Again, this is the weird thing that really screws you up with Python. Like, there's so many things that are just so easy to do in Python, and then you want to have an average of values in a list, and then it fails out on you. Then you've actually got to do real math. You can't just do AVG. Like PHP, you just do AVG, you get your average. Anyways, that's not how Python works. You actually got to do some math here. So we're going to do sum price. You do get the sum. So what sum is sum up all the values in the list so we can get that total. And then len, what len does is it gives you the total number of indexes. And that starts at 1, right? So 1, 2, 3, 4. So sum price will add up all the values. Then len price will tell you how many indexes there are. And so you're going to divide the total price by basically the items in the list, and that's going to get you the average. That's the basic math there. Then what we're going to do is we're going to return. We're going to return high, comma, low, comma, average. So we created these variable values here. We assigned values to those variables, and this is where we're returning them. So you got to do the comma in between. So it's high, comma, space, low, comma, space, average. So all 3 of these values will be sent down here to response. And then if we print out response, what we'll see is that basically this is what's called a set. So when you have parentheses, open parentheses, close parentheses, that's a set. Again, we've talked about collections a little bit. So a dictionary is a collection. Again, something that looks like a named key array in other programming languages. A list is a collection. There's also tuples and other things. Anyways, so this is basically a collection. So the first value at the index point of 0, because again, in collections, the index point starts at 0. 0 is 55.6. 1 is 11.2. 2 is 29.94, blah, 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 right? Okay, so we get that back, but that's not very useful. But that is simply a set. So we can access based off of the index. So we have print f, then max will be response at index 0, square bracket 0. Min, response at index 1. Average, AVG, is response at index 2. And this is all just one big long line. We're just simply having word wrap here to make my life a little bit easier. So now if I want to print this out here, just Control S. Basically now we can see that max is at 55.6, min it is 11.2, and the average is 29.94, blah, blah, blah. I would definitely clean that up if I was doing that in a normal script. So that's how you return multiple values. You create and set the values for the variables here. We return them here. When we return them, again, this is basically just a set. So high is at index 0, low is at index 1. Average is at index 2. And so then what we can do is we have response. So response is going to be the value that gets sent back. So we can do response index 0, response index 1, response index 2. Now this is one of those things that can get a little confusing. Sometimes if you're not really sure what the hell the function is returning, again, this is an important time to go back and actually take a look at the function and verify what you're dealing with is what you think you're dealing with. Again, notice you just have 0, 1, and 2 down here. Sometimes what happens as a programmer is in your brain, you think you remember how this is laid out, which isn't reality. What's going on in your brain isn't always a reality. And so then when you go and you start writing the rest of your code, you can start having a lot of soft errors. Again, hard errors is when your code fails. It just fails. You know there's a problem. Soft errors is when your code works badly. You just get the wrong answers. So if you forget, right, the order of these returns and you start doing stuff later, yeah, you can just get a confusing, god-awful mess that doesn't actually fail. It's like you're just looking at the code. You're looking at what's popping out, and you're like, wow, well, my code's working. I swear, I don't think those are the numbers I'm supposed to be getting, though. Those numbers seem weird, but the code's working fine. What's going on? And it's like, oh, because you mixed up. You thought low was where high is, or high is where low is, or average was the first one, and you just kind of get that mucked in your brain. So do be careful with that. But otherwise, this is basically the simple idea of how you're able to return multiple values from your function. So now that we've gone through multiple examples of functions, now I want to give you a little bit more example of that whole flow control and also the scope of variables. Because again, this is one of those stupid things that can screw you up at the end of the day. So you'll notice I have some things commented out here, and as I go through this example, I'll uncomment things and comment other things out so you can see kind of what works and what doesn't work. So the first thing that I want to show you is this whole idea of scope. And so when you create a variable value in the prime line of your script, that is accessible within the function that you're going to be calling, right? So we're going to have message equals words are cool. So this is the variable value up here. We're going to define a bad underscore function. And then basically what we're going to do right here is we're simply going to print out the message. So the message is words are cool. We're going to print out what the value of the message is, and then we're going to call the bad function here. So variable created and set, function here, call the function here, everything, the words are cool should get printed out. So we do that, and we see that words are cool. So it did work. Now, one of the things to be thinking about is, again, when we think about that flow control, you just go like, okay, well, message is set here, and then we print it out here, so that's the place that it should be. What if, do Control X, we put it here instead? So we call the message variable here, but the message is set after the function. Do you think this will work? If we run it, it will work. Words are cool. And the reason is because we do not call the function till down here. So when we call the function, the variable has already been created and assigned, so therefore we're able to print out the message. Even though that variable is created and assigned after the function, it's called before the function is called. And so that's the important thing in the Python world. If we take this, and then we put it after the function is called, right? So we have the function, we call the function, then this is the message. What do you think will happen here? The answer is it will fail. So we get this, line 5 and bad function, print message, name message is not defined. So we get a failure because we're calling the function that's been created before we assign the value for the variable that we're going to be calling, right? So this can be here, or it can be up at the top, but it can't be after the function is called. So again, that's one of the things we talk about with this whole code flow. And believe me, once this code starts getting more and more complicated, this can be a wee bit frustrating, right? So now I want to take a look at the idea of local variable values. So we created this variable, we set the value up here, and we're able to call it from within our script. So if we had, or within our function, so we had 20 different functions, all those functions would be able to call that variable value. So in our function here, though, we create a variable called bad underscore var equals Bob, and then what I want to do is call that variable down here, right? So basically, I'm assigning it, I'm creating it and setting the value within the function, and then will I be able to access it here? If I go, what we'll see is bad var is not defined. And the reason is because it's a local variable. And so when we try to access it from outside the function, it fails because its scope is only simply within the function. So the interesting thing here is we can then do this thing called global. So this is not something that you should do. This is considered bad programming practice that nobody would ever do. Ever, I swear. What global bad var does is this turns your variable into a global variable. So basically, it's accessible from anywhere in the script. The idea with Python is that you should always return variable values and then do something. The return is the proper way of dealing with variable values. The global way is, again, something that in fact does work. So if we say global bad var, we set the value for bad var to be Bob here, and then we print out bad var down here. This will work. Right now we see Bob is printed out because we turned this bad var variable, local variable, to have a global scope here. So once you do that global, it will be accessible. Except, remember we're talking about flow control, the flow of the script? So if we have bad function here, so we're going through, right? We define the function here. We call the function here, so that actually brings it into the script, and then we go through and we create the variable, we assign the variable, and then we print it out here. What do you think happens if I simply comment out calling the bad function? So we have a global variable, the global bad var variable, in the bad function, but we're not calling the function right now in this particular script. When I do this, I now get an error. Again, because of flow control. Because although we have this function here, we did not run the function so that the variable can be set, so therefore it fails out. So not only with this function, not only with this, do I have to make bad var a global variable, but I have to make sure that before I call that global variable, somehow this function has been triggered so that all of this code runs properly. And that, my friends, is why people give up on learning how to program. They don't necessarily fail because, that's 11 lines of very stupid code. Start imagining this on a much larger level. And again, that's where, like in the Python world, understanding how the flow control works, making sure you write things appropriately when we talk about styling is important, because also it's not just about you, right? So much in the modern world, it's about you, which is great for other people, right? If you want to be a florist, you just be as self-involved as you want to be. I'm not saying being, egotistical and self-involved is a bad thing. I'm just saying it's a bad thing in the technology world, right? And so one of the things to be thinking about, like with this flow control, is when you hand this code off to the person that's going to replace you, your code may work perfectly, but when somebody tries to go through and read what the hell you created, right? It may be a very bad life for them, as, again, if you've got all this mixed up in Willy Wonka type ways, they could know exactly what they need to do and just not understand exactly how everything in your code communicates with each other, and they could be just having a bad life. So anyways, so this is kind of that example of flow control. This is an example of scope, just to show you, what's going on when your scripts fail as you're playing around with this. So now, as we finish up this class, I wanted to give you an example that's a little bit more complicated again, so you can start getting into your brain the idea of why we use functions and why that reusability is so important. When you're doing 2 or 3 line functions, you may grasp the concept, but when you start to do these longer and longer functions, I think it really hammers in home why functions are important. So for this particular function, this is a mortgage repayment function. So the idea, you're buying a house that has an interest rate on the house, you're making a monthly payment. So the idea here is, how long will it take you to pay off the house? How much are you going to pay in total for that house? And how much will you have paid in interest by the time it's over, right? So we're going to print out repayment in years, the total amount that was paid, and the interest paid. To take a look at this before we get in the function, so we're going to have price. We're going to have a global variable of price equals 100,000. Interest is going to equal 7 for 7%, and payment is going to equal $2,300 a month. Response is going to equal calling the mortgage function, sending price, payment, and interest, and you'll notice those are swapped around. That's okay, right? So basically, you're just plugging in. Here is where it matters. So price at index 0, payment at index 1. interest at index 2. We're going to send those up to this little mortgage calculator. So we're going to define the mortgage function total payment interest. And again, you'll notice down here it's price payment interest. The name doesn't matter when it comes up here. It's index 0, index 1, index 2. So total is the same as price, payment is payment, interest is interest. Then we do the colon. Then one of the things we have to look at is basic math. Again, a lot of people are like, Eli, do you need to be good at math to program? And it's like, well, it depends on what good means. Do you need to know trigonometry and calculus? No. Do you need to understand what that is? Yes. If you can figure this out or some of these other ones out, you'll be fine. If this is a bridge too far. Anyway, so we need to get the actual interest rate. So we need to get it down for a monthly interest rate, and then we need to get that down to decimal places. So we have 7. So set for 7%, we need to get 7% down to 0.07. So you need to multiply by the interest rate in order to get the interest payment. And so if you multiply by 7, everything's going to go to hell. You need to multiply by 0.07, right? Not only that, you actually need to divide 0.07 by 12 to get the monthly interest rate. And so that's what we're doing here. So the interest that we're going to be using within this function is going to equal the interest that came in divided by 12. So 7 comes in. So 7 divided by 12 gives you the interest rate on a monthly basis. Then we're going to divide that by 100 to take it from whatever that number is. And basically by dividing by 100, you move the decimal place 2 points to the left. So now it'll be 0.00 whatever the monthly interest rate is. Month, so we're going to be using months as a way to count this. So we're going to create that local variable as month, and we're going to set it to 0. We're going to create the local variable of paid. We're going to set that to 0. We're going to have the total interest, and we're going to set that to 0. While total is greater than or equal to 0. So while the total has not been paid off, can keep doing this loop. The first thing that we're going to do is total interest. So total interest equals total times interest plus total interest. So the total amount that is currently owed times whatever your interest rate is plus however much you've already paid for total interest, that will be the value for total interest, right? So there'll be an interest payment this time and next time and next time and next time and next time, and then it just keeps getting added up. Total is then going to equal total equals total minus payment. So you have the total amount minus 2,300. That is now the value of total, right? But not only that, we do have to add that interest to it. So total equals total times interest. So total times the interest rate. This will tell you how much you've been charged for interest for this month plus total. So total comes down, and then total goes back up a little bit. Again, this is kind of the math thing, and I realize I probably screwed this up. Extra points for the kids at home if you understand how I screwed this math up. Again, when we start talking about flow and order, this is the thing that will really screw you up. It's not the trigonometry. It's when do you charge interest? When do you charge interest versus when do you log charging interest? So what's interesting here, this is where I actually screwed up. Did you catch it? I log charging interest here, but I actually count the charging interest here. So those are going to be off by a little bit. Again, very, very simple math, but what is the order of everything? I really should have put this above the total minus payment, or I should have put those below the total minus payment. That's the kind of thing that's going to be important for you. And again, that's the whole thing. Like when you're creating some kind of membership script or anything where there's payments or whatever, again, are you logging what's actually coming out of the account? Or are you logging at a different level from what's taking something out of the account, making sure that all works? This truly is a bit off. Paid. So this is the amount that's going to be paid. Paid equals paid, what has been paid in the past, plus payment. Month plus equals 1. So plus equals 1 iterates by 1. Once we break out of this loop, once we go to 0 or below 0, year is going to equal month divided by 12. Basic math there. Then we're simply going to return year at index 0, paid at index 1, total interest at index 2. So response is going to be response 0 is going to be year. Response 1 is going to be how much was paid. Response 2 is going to be total interest. And that's repayment in years. Response 0. Total paid, response 1. Interest paid, response 2. And so when I run this, hopefully it works fine. So if I'm paying a $100,000 loan at 7% interest at $2,300 a year, it'll take 4.1 blah, 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 4.16 years to repay. The total that I will have paid will be $115,000, and the interest paid will be $15,000 and 15 point, and $1,500. Again, that's where you got to go through and make sure all your math is quite right. I apologize for all the Aspies out there. I'm probably making your brain melt a little bit. But then I can go back, and again, with this, I can tweak things. What if I paid, $4,000 a month, and then I run this, and I can pay it back in 2.25 years. I'll pay $108,000 in total, and again, around $8,000 in interest. Again, this is just my crappy math. It's not the problem of a function. One of the curious things, though, is when I was writing this code, and again, just to show you the problems you can run into, is I set these values. So originally, when I was going to do this example for you, I was simply going to do the total price and do the payment and show you how that works as a function. That's all I was going to do. And so I wrote out that function, and it worked fine. It was like a $10,000 loan. I was paying $55 a month, and it got paid off in however many years. But I was thinking, well, that's not complicated enough. I got to give these folks something a little bit more complicated than that. So I added the interest. And then the funny thing happened. I added the interest, and then I started getting this error. So let's say I pay $400 a month, and then I run this. And then it would just lock up. Look at it. It's just locked. I'm not getting a response. I'm not getting anything. It just locks up, right? It just locks into a while loop for some reason. I was like, crap, what is that? What's going on? So I do a Control C, so I break out of it. And again, I'm doing exactly what you guys are doing. I'm like, what did I write wrong? I'm like, I did parentheses, right? So I'm doing all this stuff. I'm like, I just don't understand. So then I'm like, okay, so let me just do something, right? So let me, again, for troubleshooting purposes, let me go print, and I do total here. So again, as this goes through, it'll print total. Okay, let's see what's going on here, right? Do a little save, and so I hit run, and see how I had those numbers? All those numbers are showing up. And then I get this. I'm like, crap, what is this? What's going on? I don't understand. It's like, God. I'm like, come on now. This is a really simple class. This is functions. This isn't supposed to be complicated. What's going on? And after I play with this a little bit, what I realized was the payment is so low that on a 7% interest rate, if I'm only paying $400 or $55 or whatever else, I will literally never repay the loan, right? So this is a while loop. It will continue to loop until it's true. Here's the thing. If the amount you're charged on interest is more than your payment, that loop will never break. And so what'll happen is you will get your code to freeze up. And this is one of the big problems you get to. Again, I talk about that like with while true loops. So what a while true loop is basically it's a loop that the conditions never get met. So it just loops forever, which can be brutal if you're making API calls that cost you 1 cent a piece. But anywho, right? And so I ran into that issue here. And again, I actually spent a lot of time rewriting this stupid-ass code because I don't understand. So one of the things to think about, and again, this is when you start writing code in the real world, is you've got to test. Again, why testing is so important is so that you find these edge cases. Who's going to be paying $55 a month on a $100,000 a year loan? There's going to be people out there that try. And if you don't try, you're not going to see the failure. So basically, what I have here now is I do if payment is greater than total times interest, right? So total times interest will tell me what that interest payment is. So if the payment is greater than the interest payment, then we have the while loop, and then we create total interest and paid and all of that kind of stuff. Else here, print on the screen, minimum payment is too low to ever be paid off, month equals error, paid equals error, total interest equals error. So you're going to be calling these variable values down here. So if you don't set these values to something, you're also going to just get a Python error. So I'm setting these to error, right? So if I pay $7,000 a month on a $100,000 a year loan, and I run this, it'll show me it takes 1.25 years. I'll pay $105,000, and it'll be about $5,000 in interest paid, which is what you can expect. If I try to pay $70 a year or $70 a month on a $100,000 loan, if I save this and I run this, and what we'll see, okay, is that $70, minimum payment is too low to ever be paid off, repayment in years, error, total paid error, interest paid error, and so we get that error. And so again, we get that fail out to understand that there's a problem. And again, that's where again, trying to figure out where the errors in your code are can be very difficult. And again, imagine if you're pulling values in from multiple places, and every once in a while you just get this random failure and you're trying to figure out what's going on. So putting into your code very simple things like the payment is greater than the interest payment is just an easy way to make sure that, I don't know, everything doesn't get goofed up for you. So there you go. Now you have learned how to write functions in Python. And like I say, it's relatively easy. You're going to want to start using it as functions as much as possible. Again, to have that reusable code. So whatever it is that you're trying to do, you can simply create that as a function. And then if you need to modify things or if there's a problem, you can go back to that specific function and change whatever is there. Not only will that be easier for you at the end of the day, but again, when you hand this code off to somebody else, it will make their life much easier. I really want to hammer into your head, again, in this modern world, it's all about you, me. And again, that's great, right? If you want to be a florist, if you want to be a YouTuber, I don't know, if you want to be a doctor, be me all you want. In the technology world, though, that is literally not how we work. Every time I go onto YouTube and I'll hear like manosphere stuff about alpha males, it just makes me want to cringe. Because again, maybe in their world, that's how this crap works. In our world, we are a team. Now, there's people on the team you want to work with, and there's people on the team you don't want to work with. That's its own mess. I'll let you figure out. But again, this whole me thing just isn't how we operate. You need to be able to interact and work as a team. And you need to be able to work as a team to such a degree that you're actually a team member for somebody that may be working for your company 5 years after you quit. Right? When somebody 5 years after you quit opens up your code and goes, wow, I'm so happy this was written in such a way that I actually understand what the hell's going on. That means that you're really being a team member, again, long after you're gone. And in our field, that kind of thing matters. That kind of thing is noticed and remembered, and that's what will make you successful. If you write code that nobody else can maintain, do not be surprised when you're one of the first to be laid off, right? It's just kind of how it goes. Kind of weird that, right? And people think, well, if I write this code so complicated nobody else understands it, that gives me job security. No. That just means the manager is trying to figure out a reason to fire you. But anyways, showed you the functions, all pretty simple. Again, with most of this, when we talk about the variables, you can do global variables. We talked about that scope, global variables and local variables. You can turn local variables into global variables by using that global. Generally, do not do that. For functions, you should return a value and then deal with it however you want to deal with it. Do remember the flow order, though. That can really kill you, especially as this stuff starts getting more and more complicated. You have your functions, you assign your variables, but then remember, whatever happens in that function doesn't happen until the function is actually called. So you may have a function in your script, but if you don't call it, and again, you can do something like create a global variable, your script won't work right because the function itself hasn't been called. Everything in that function isn't actually pulled into the runtime until you call the function. And then again, like I showed you, where you can have a variable set before the function and it works. You can have a variable set after the function and it works. If you have the variable set after you call the function, it will fail because the variable has not been set before you call the function. The calling of the function is the thing that really, brings everything into that runtime environment. Again, showed you a lot of different stuff here. I would say go play. We're going to be dealing with functions quite a bit as we get into the more complicated things, dealing with the operating system, dealing with API calls and all that kind of thing. You'll start to use these functions more and more. One of the big things I do want you to play with, though, is again, when you're creating the functions, creating things like while loops, again, do testing on this. Push them. Again, pay $1 per month on a $100,000 loan, or pay $500,000 a month on a $100,000 loan. See what happens, right? Nobody would do that. Well, you might want to plug it into your code, see what happens. And if you get a problem, that's where you can use your if-else statements, those other things to try to catch what that problem is, and then fail out in a way that you can understand. Again, when I showed you that mortgage script, when it fails out, it prints out. Prints out the payment is so low you'll never pay off your loan, and you're like, oh, the payment's so low, I'll never pay off my loan. Okay, now I can go back and try to fix things. That's the kind of stuff that you really need to be thinking about with your code and writing all this kind of stuff. So yeah, I guess that's about all there is. So as always, I enjoy teaching this class, and I look forward to seeing you at the next one.